Okay, today we're talking about section 4.8, matrices for rotations. Some of you will find that rotations are the hardest ones because visually there's just so much going on that it's just not a flip over an axis. Some of you will find them quite easy. But either way, we're going to give you 3 more matrices that go for our list of total transformations to date. So we will recognize the relationships between the figure and the rotations. We will relate the rotations to matrices and also be able to graph them. So let's get started. One thing discussed in the textbook was if you have a rotation, and from geometry you can say, well, we rotated 30 degrees and we followed that with a rotation of 40 degrees. And so what did we rotate totally? 70 degrees, 30 plus 40. So that same rule applies here. So a rotation of b degrees following a rotation of a degrees with the same center, so everything has been centered so far at 0, 0, results in a rotation of a plus b degrees. Even if you did a positive rotation with a negative rotation, you should still be able to add the positive with the negative and get the total results. So in symbol form, our rotations are now going to be capital letters, so new symbol here. Rotation of b degrees follows a rotation of a degrees, and it would give us a rotation of a plus b degrees. So capital R is our rotation, and remember we've already had little r was our reflections. So any transformation that represents a reflection, we're using little r. Rotations, we're using capital R. All right, I also put our 1, 0, 0, 1 points on there and be able to rotate them. So let's try to come up with our 2 by 2 matrices using our original points. And let's start with the rotation of 90 degrees. So let's take our points, which were 1, 0, and 0, 1, and let's rotate them each 90 degrees. So if I took the point 1, 0, rotated at 90 degrees, it would rotate there. Now I've got them stuck together, so let's rotate them 90 degrees. If I would rotate 90 degrees, is that going to rotate my whole shape? Hang on one. I'm going to unlock those for a second. So if I would rotate the first point, 1, 0, it would go here. So that would be the point 0, 1. And if I took my point 0, 1 and rotated it 90 degrees, whoops, not with a pen though, it would have gone, didn't like me, it would have gone to negative 1, 0. So we had the situation where this point went here, and then our blue point went there. We went 90 degrees. So let's write our new matrix for both of those for 90 degree rotation. Okay, our point 1, 0 went to 0, 1, and our point 0, 1 went to negative 1, 0. Okay, let's continue from there. Let's take these points actually back before we do that. Let's take it back, and let's take that one back. All right, here we go. We're back at the original. If I now take the point 1, 0 and rotate it 180, that would put it here. And I took my point 0, 1 and rotated 180, that would take it here. So again, write your matrix using that description. We would have had the point 1, 0 became the point negative 1, 0, and the point 0, 1 became 0, negative 1. We're ready for 270. Again, take our points back to where they started so you can visualize. Here we go. The point 1, 0 90, 180, 270, lands right there. Again, this point travels 90, 180, 270, and it travels there. So look and see where we're at. The point 10. The green became the point 0, -1. And our point 0, 1 became the point 1, 0. So there are our 3 matrices for rotation. Very easy to change just our 2 points that we have, and we're going to use those as we move forward for our 2x2s in any of the transformations we do. So if those are our rotations for 90, 180, and 270, and you see them here, the matrices we just came up with, let's find out what really happens to an XY ordered pair. Because a lot of people will say, you know, hey, if I just found a point out here, what would happen to it if I rotated it 80? Well, it's a little harder when you're not on the axis to rotate, because you say, well, okay, where's 90 exactly? Do I stop here? Do I stop, you know, where do I stop? That's usually the situation. So let's do them one at a time. So let's go with rotation of 90, and let's multiply it out. 0 times x, 0. -1 times y is -y. Second row, first column, 1 times x is x, 0 times y is 0, added together is x. That should be our shortcut, which means xy becomes the ordered pair, the opposite of y, x. So notice, x changes to y, and y changes to x, and becomes its opposite. So if you like it as ordered pairs better, you could say xy turns into -y, x. All right, let's do the same thing for 180. Multiply it first. First row, first column, -1 times x plus 0 times y adds together and gives us -x. 0 times x and -1 times y adds together and gives us -y, or the opposite of y if you like that. So xy, our original point, became the point opposite of x, opposite of y. Last one, rotation of 270. 0 times 1 is, or 0 times x is 0. 1 times y is y. Second row, first column, -1 times x is -x. 0 times y is 0. Added together is -x. Again, if you like it left to right, the ordered pair xy becomes the point y, opposite of x. So notice, x and y are switching positions on 2 of them, rotation of 90, rotation 270, where x and y are staying the same but turning to their opposites on 180. So let's put it all together and check your sheet, because now you have about 9 of them, do you not? So double check, add the name to the name column, the notation, capital R's on all of these for the rotation symbol, our new 3 2x2 matrices, and then the shortcuts that we just talked about. Okay, take a second to get those written down. And then you can work several ways. You can work with just the matrices sometimes. You can work with the shortcuts. That's what we really like. And these are the ones that are not, as I say, as visual as the others. So if you need to memorize, basically these would be the 3 I say, just out and out memorize them. Opposite of y, comma x is 90. Opposite of x, comma y is 180. And y, comma the opposite of x is 270. So now, what type of problems are we going to be working on? Find the matrix for reflection over the x follows a reflection over the y. What does this represent? So you're actually being asked here to go back and use some of your reflection ones. Reflection of the x follows reflection of the y. So that means if this was my matrix for my shape, okay, that would be there. Even though they didn't give me one, I would have to do r sub y, and then I'd have to do r sub x. So closest to the shape is the one I do first. And then again, remember, reflection over the y-axis was where the x value changes to its opposite and the y value stays the same. And then the reflection over the x-axis where the x value stays the same and the y value changes to its opposite. So there's our two matrices that we should be getting used to writing. And now let's multiply them. First row, first column. We know we're going to get 4 slots because it's 2 by 2 times a 2 by 2. So first row, first column. Reminder, I'll just use colors this time. First row, first column, you're doing 1 times -1, 0 times 0. Added together is a -1. Next color, we need to do first row, second column. 1 times 0 is 0. 0 times 1 is 0. Added together is 0. Now we're in the second row, first column. 0 times -1 is 0. -1 times 0 is 0. And last but not least, if we do second row, second column, we're at 0 times 0 is 0. -1 times 1 is -1. Added together is -1. So we got a -1, 0, 0, -1. Now, take a look at your new list, because this says find the matrix and what does this represent. So you would have to be able to say now that this actually equals a rotation of 180. Where did I get that? I looked at my list and we had just done those 3 matrices and that matched the rotation of 180 exactly. So anytime you do a reflection of x followed by a reflection of y, you can say that's the same as a rotation of 180. It would be simpler just to do the 1 rather than 2. So that's what we're looking at here. What relationships are you seeing? One more. If we have a triangle, ABC, and its vertices are given, it says find the image of triangle ABC under a rotation of 180. So it says find the image. So let's start and let's put ABC in our matrix 0, 4, 0, -4, and 4, 0. So there's our ABC matrix. It's a 2 by 3. And if we want to find the image of that triangle under a rotation of 180, you have 2 choices. You have your, I could do matrix multiplication with the rotation of 180 matrix, or you also now have a shortcut that says x, y turns into the opposite of y, or opposite of x, opposite of y, ordered pair. We have either one of those. So however you choose to set yours up, if you want to multiply, I like the shortcuts in this case, which says keep x and y where they're at, but change them to their opposites, so we can do that. 0 stays 0, because 0 is its own opposite, and the -4 becomes a 4, and then the 4 would become a -4, and the 0 would stay 0. You do not have to put -0. So that would be what our graph should be. We could then graph it if we needed to. Also, if we would have done a matrix multiplication, we should have gotten those same points. So either way, I'd stick with shortcuts when you can, but it's up to you. It'll take a little longer to do the matrix multiplication, but if you're comfortable with that, there's nothing wrong with that either. So we've got 3 more added to our list: rotations, reflections, transformations are up next, but we've also had scale change and size change. So I think we have 8 or 9 of them now in our list total. I think it's 9 with just the translations to add. So good job, and work on these and bring any questions you have to class with you.